Okay, in this question, we are talking about to solve the following equations, part A up to part D, and let's see the solution one by one. Part A, when we talk about log x equals 0.12, actually, you will see that there is a common log with base 10. So we omit number 10 here. We did not write it down. But actually, it's the standard format of the logarithm equation. Log b base a equals a constant n. And therefore, if we want to change it back into the exponential equation, we will write in this way. That is, b equals a to the power n. Remember, this base a is always in here with the power n. So you can use your calculator to find value of x. And x you will get is 1.32, correct to three significant figures. That's it. That's the part A. And now let's move to part B. When it comes to part B, you can see that there are variables in the index on both sides. 10 to the power x equals 3 to the power x plus 1. If you want to move the variable from index to the coefficient, you need to take log on both sides. But the problem is, what is the base you choose? You can choose either taking common log on both sides, or you can choose to taking log base 3 on both sides. Because you can see that the base are 10 and 3 on different sides respectively. So if you take either common log or log base 3, you could simplify this equation easily. But now let us focus on the first one. Take common log on both sides, and then we go to the second one. If we have a log in here, you can move the index in front of log, become x times log 10 equals bracket x plus 1 times log 3. Remember, whole index x plus 1 will follow 3. So you need to move whole index x plus 1 in front of log. And some of you stop here because they don't know how to simplify it. You can just treat log 3 as a number only. You need to do the expansion to remove the bracket. And log 10 equals 1, so left hand side remain x. Right hand side will be x log 3 plus log 3. Now, move all terms with x on left hand side. You will have x minus x log 3 equals log 3. And now you can take out common factor x bracket 1 minus log 3 equals log 3. Now you can move this bracket to another side, become division. Log 3 divided by 1 minus log 3. And you get x equals 0.912. That's the first method you handle this question. But if you do not want to take common log, you want to take log base 3, you can get the same result. Here you can see that if we take log base 3, you can get the same result. But in here, the left hand side will be x times log 10 base 3. Right hand side will be x plus 1 because log 3 base 3 equals 1. Again, you move all terms with x on left hand side. Right hand side will remain 1. So you take out common factor x and then divide this one to another side. You get the same answer for part B. Now it comes to part C. Log 3x plus 4 minus log bracket x minus 1 equals 1. You can see it is quite obvious. Using the log property, log m minus log n equals log bracket m over n. So this becomes log bracket 3x plus 4 over x minus 1 equals 1. Again, that's a very standard logarithm equation with the base 10. Therefore, we can transform it into exponential equation. That is 3x plus 4 over x minus 1 will equals 10. Because the base is 10 here. And then we can solve this equation to get the final answer. So you get x equals 2. Simple. Finally, we are talking about question part D. And you can see that there's a very standard logarithm equation format, log b base x equals n. Again, we need to change it back into exponential format. That is, x to the power 5 equals 32. Now, you take the fifth root on both sides, or you can take the power 1 over 5 on both sides. So we write in this way, x equals 32 to the power 1 over 5, and hence x equals 2. That's it.